Okay, so in that first worksheet, we looked at using this form of the normal distribution. And you saw that required a lot of typing. Wouldn't it be nice if we had an easier way of doing this normal distribution? Of course it would. Would Excel be so kind to do that for us? Of course it will. It is going to require, though, three parameters to calculate the normal distribution at a point. We will need the point we're looking at, the mean, and the standard deviation. And to find the normal distribution at a point, we use the function normDist. Normal distribution, normDist. Requires the point, the mean of my distribution, standard deviation, and it's going to use one other parameter, false. We'll explain why we have this one extra parameter, false, next chapter, but for now just accept that you have to type in the word false. Briefly, for a brief explanation, I'll put it this way. Excel uses normDist for two different purposes. For the purpose of finding the normDist at a point, we need this last parameter to say false. This function, this Excel function, normDist, will yield the result of this equation right here. After we complete this little explanation, you'll be prepared to do the exercise, it's all normal. Okay, so last time we used this long equation up here to calculate the normal distribution, giving us this curve there. And I said that we can use this function called normDist. I'm going to show you how that works. Make this column just a little bit narrower. I'm going to copy and paste the column once. Here's my formula. I'm going to need to hold something else constant. Actually, I don't want this at all, do I? What I want is the function normDist. See, this normDist, it returns the normal cumulative distribution for a specified mean and standard deviation of my position, comma, my mean, my standard deviation, the cumulative, I'm going to use false because I'm just looking for the probability distribution function. False. There we go. So you gave me 0. I'm going to copy and paste this almost all the way down. Actually, I'm going to put some dollar signs in front of these row numbers for the standard deviation, mean, and I'm going to put a dollar sign in front of the column number for my position so I can facilitate some future efforts. Copy, paste. Now, let's take a look down here. Notice how I'm getting the exact same numbers because this normDist function is equivalent to that normal probability. Of course, this long equation is a bit more difficult to use than that simple function. So for the rest of this chapter, we'll be using this simple function, normDist. Just wanted to show you that you can calculate the normal probability using the raw formula or by using an advanced Excel function, such as normDist. Let's take a look at normDist at a couple of different points. I'm going to paste this here. There we have it. Let's see what happens as I change my normal distribution mean to different numbers, like 35 or, I don't know, 75. Let's plot those. Here, I'm going to change this so that I'm using the normal probability. There we go. There we have it. Let's go ahead and add in a few more aspects, like the other portions of this plot. I'm going to add in, there we have, select data, add series name, mean of 35, series values here. Okay, okay. I'm going to add mean, series name 75, series values here. Okay, okay. Category axis, I want to make sure I have the right stuff. Okay, okay. let's take a look at the plot that was resulting of this. Notice that my mean at 50, this blue curve, peaks exactly at 50, as it should. It's most likely to find the measurement at 50. My mean at 35 peaks at or around 35, at 35, with some distribution. My mean at 75, that curve will peak at 75. In other words, with the mean at 75, it is most likely you will find the measurement at 75. If the mean is 50, it's most likely you'll find the measurement at 50. If the mean is 35, it's most likely you'll find the measurement at 35. You can have fun with this, like just start playing with it. Try moving it around. Notice I'm just typing in other numbers. See? 30, 40, 50, 60. So you get the idea. I'm going to put it back to 35. So that's my normal probability distribution with different means. I'm going to copy. Actually, I'm just going to move this across. Let's now play with our standard deviation. Copy and paste this entire area a couple more times. This time making the mean both 50, but playing with different standard deviations. Let's make a standard deviation very narrow, 1, and something very wide, like 15. Okay. I'm going to copy and paste my entire plot. I'm going to change what's being plotted. First of all the titles change. Actually, we change it this way. Select data, remove, add, series name, 50, series values. Have it? Okay. We change it so that the series names reflect the standard deviation. I'm going to add in another one. Series name, the standard deviation of 15. Same normal distribution. Series values are here. Okay. Sure I have the right measurements. And I also have to make sure I have all of the data. There we go. Okay. Now this is my normal probability distribution with a mean, mu, equal 50 different standard deviation. Let's make this mu look like a mu by changing the font into a symbol. There we go. I'm going to scroll out just a little bit and scroll back in. Let's just take a look at this plot. Notice that regardless of the mu, 1, 5, or 15, all of these seem to peak around 50. When the standard deviation is very small at 1, this peaks very sharply and very highly at exactly 50. At the standard deviation of 5, peaks a little bit more slowly around 5. The standard deviation of 15 is very broadly distributed, but it's still peaking around 50. Now let's compare these plots together. And you see how the effect of changing the standard deviation is to make the normal distribution wider and thinner. The larger the standard deviation, going from 1, 5, and 15, the broader the normal distribution. The smaller the standard deviation, 1, the more narrow the distribution. When we change the mean, we just change where it peaks. This is a good example of the normal curve. You can see these curves in your book on page 73 and 74.